Welcome to the micro communication course. We start here with a new topic, a microstrip antenna. So in a microstrip antenna, we already learn a microstrip line. So similar kind of a structure that is about a small strip is there, small strip-like structure or small patch-like structure will be there. So that's why that antenna is called as a microstrip antenna. Okay, that strip it is about a simple patch is there. So even if you see the other books also, they have mentioned that a patch antenna is of a microstrip antenna. So even if you search that, this particular antenna is called as a patch antenna. And this microstrip antenna, if you see, this antenna is about a high performance antenna, okay, and it is to be used at a aircraft, spacecraft, satellite, and a missile application. Because this microstrip antenna, its size is very small there. Okay, so small size antenna. This one is about we can say that a small size. This one characteristics of the antenna we say that it has a small weight. Okay, low weight, not small. It has a low weight here, and if you design this particular antenna, so that antenna can be designed using a simple printed circuit board or your PCB here. So that's why the cost of the antenna is about a very low. Okay, and then if you see the performance, okay, so so as per the other antennas, so this performance of the microstrip antenna is very good here. You can say performance here. Okay, it has a good performance as compared to the other antenna, and this antenna generally used as a receiver one. Okay, so and if you design this particular antenna, we can easily install this particular antenna there. We can say that installation is very easy. So that's why you can say that is of installation here. Okay, then it has a if you it has the aerodynamic profile there. So that's why that the particular antenna is to be used in a aircraft or a spacecraft, or we can say that this antenna can be used for the satellite or a missile application here. Okay, then because of all the features, we say that this antenna is called as a low profile antenna. Okay, this antenna is called as a low profile antenna. But how to design? Just like this antenna, we say that it is about a low profile antenna. Okay, so we can simple design or manufacture or develop this particular antenna using a simple printed circuit board technology. Okay, that is about a PCB. Okay, you can use a PCB there, and we supposed to use that particular design, that printed circuit board to design that PCB is to use to design simple patch like a structure. Okay, this particular patch is to be developed on the APCB there. So that patch will be of a various shape. It can be a rectangular shape, triangular shape, circular shape. Okay, we'll see that what are the various shapes of that particular patch antenna. The patch are there, and that patch are easily designed or developed on the APCB there. So if you consider in terms of a frequency, okay, so or we can say that how this particular antenna is work. Generally, we supposed to say that this one is about a broadband antenna. Okay, so it will work at high frequencies. So that's why we supposed to consider that this antenna is called as a broadband antenna. But if you consider the other configurations, okay, so that broadband horn antenna is again a broadband antenna, then a reflector dish antenna or a reflector antenna is again a broadband antenna. So according to that, the categories of a broadband antenna is different because it is work at high frequency and wider bandwidth there. Okay, we not talk about that bandwidth here right now. So we just talk about that. What are the other parameters to be considered uh, so that this microstrip antenna will be useful, or you can use this microstrip antenna for the various applications there. So now We can say that this particular antenna, so if you talk about that the frequency, then what type of a polarization pattern is there, and what will be the impedance, and how to calculate that a total impedance of this given antenna. It will be very easy. So we should know that what will be the size of a patch there, and what will be the thickness of this particular patch, and according to that we can calculate the parameter of the antenna there. So only that main difference of this particular antenna, the microstrip antenna, it has a low efficiency, low power, high Q, poor polarization purity, poor scan performance. Okay, so that's why we say that this particular antenna is used as a receiver. Okay, so we can say that what are the disadvantages there? Disadvantages are nothing but what? It has a low efficiency. Okay, you can say that it has a low efficiency, low power. Okay, then we can say that it has a high Q. Okay, that high Q value, that is about, we can say that high Q means what? It will be above 100. Okay, we can say that it is greater than the 100. Okay, excess of 100. So that we can say that value of Q here, a number. So then we can say that a poor polarization purity. Polarization means what? We say earlier that electric field vector, how it looks like. Okay, vertical, horizontal, likewise. That is nothing but a polarization. Okay, so in that case, we talk about the what we are using, what supposed to be transmitting. Okay, which type of antenna, whether it is a vertically polarized or a horizontally polarized one. That structure, because the patch is there, so that's why patch is difficult to design develop for the given particular polarization. Okay, but we can use it. But that's why we say that it has a poor polarization purity. Then a poor scan performance, because that okay beam, if you see that radiation pattern of this antenna, okay, so that is about a wide one. Okay, so generally according to the patch structure, suppose we have developed a dipole on the patch, then that radiation pattern will be likewise. Okay, so if we develop a, okay, so loop, then we that. Okay, so likewise, so radiation pattern, how your radiation pattern will be there, it can be unidirectional also. How we can develop a microstrip antenna there, so we can get the unidirectional radiation pattern also. So for that purpose we have to use a various patch to develop an array antenna, not only a single patch, multiple patches to be used to get the scanning performance better there. Okay, so that's why we say that a patch array antenna, okay, or a microstrip array antenna. Okay, so this one we supposed to say that. Then poor scan performance. Then we can say that it has a poor spurious, okay, spurious speed radiation. Okay, now that is about a feeding. Okay, how we are feeding this antenna. So that's why you can say that it has a spurious feed radiation there. Okay, that whatever the feed we are using, that feed is to be used as a irradiator. That's just like a point source. Whatever the feed we have. So generally, a point source is nothing but what? If supposed to be wire is open now. Okay, now this tip is will be open right now. So that tip is act as an antenna. So that is nothing but a point source here. Okay, so we can say that how your radiation will be takes place from the given particular antenna there. Then we say that this antenna is to be used for the broadband purpose. So we supposed to develop a patch and all there. Okay. So but if you consider that for a given single particular patch, okay, single antenna, it has a narrow bandwidth. Okay, so we talk about that frequency band, we say broadband. So how it is to be utilized, that particular feature. Okay, so that's why this particular patch and microstrip patch antenna, At high frequency it is to be used, so that's why we say broadband antenna, but it has a bandwidth will be a narrow one. Okay, so we can say that it has a very narrow frequency band. Okay, very narrow frequency band. Then we can consider that these are the disadvantage, but we ask, see, we have seen earlier it has a small size and all the features. Okay, that characteristics. So that are nothing but the applications. Okay, so we can use this antenna for the various applications because it has the uh, what we can say that the size is small. Okay, so weight is a low weight we have. Okay, cost and performance is of installation. So that's why it is to be used at a aircraft, spacecraft, satellite, and missile applications. Okay, that is about what you can say that the applications of the antenna there. But in the terms of a what we can say the bandwidth, okay, it will be difficult to use this particular antenna there. Mostly, if you consider that the operating band of this given antenna will be of what, a VHF, or somewhat we can consider that as a UHF band. Okay, that is about a antenna. This one is to be used. So then we say that earlier that a bandwidth and a broadband. Okay, so likewise, so that different topic. Okay, then we say that a what you can, that's about a low scan profile. Okay, that is again a different profile. Okay, low scan profile. Okay, all other factors are a different one, so that are not related to each other. So everything is depending upon that what will be the structure or a size of the patch of an antenna there. So generally basic structure, or we can say that a basic configuration of a microstrip antenna, if you see that it has a small section of a patch on the PCB. If you have seen any PCB, two-side PCB there, okay, we just consider that a two-side PCB. So in a two-side PCB, in between the ground plane there is a substrate, and on that particular substrate, okay, whatever the material we are using, according to that, that sub that epsilon value of the given substrate will be vary. Okay, so we can say that this one, this one is about a substrate there, and then below that there is a ground plane. Okay, so in between that substrate, this one, okay, very small. Okay, it's very small, thin. Okay, so otherwise what will happen? You will get confused. So why I draw a big one? Okay, it is about a very small, thin ground structure. This one is about a ground now. One we say this one is about a, we say we have the a ground plane now. One is nothing but a ground plane. So now if you see that a microstrip line earlier, so ground plane is there, above there is a substrate, and above there is a line. But instead of a line here, okay, instead of a line, it has some particular patch section. Okay, that patch section is about what? This one. We have the patch section is there. This one is about a patch section, and this patch section is connected to the a line, and so that we can feed it. Okay, this one is about your patch. You can say that this one is about a patch, and that patch is had a size. Okay, we can say that patch is has a length there. Then this patch it has a width now, and then patch it has a thickness. Okay, this particular patch it has a some particular thickness there. So we can say here another word. This one is about a thickness of the patch here. Okay, this one. This one is about your microstrip patch now. It's about not one, only one line we supposed to draw. Okay, so likewise. So now from your end, if you see that this one is about the thickness of the your particular patch, and generally, if microstrip antenna, if you consider here, So that thickness of this particular microstrip patch is very very thin. Okay, and that thickness is very very less than the what will be the free space wavelength. So in another term, we say that thickness, that T, is very very less than this lambda zero, and that lambda zero is nothing but what, a free space wavelength, right? So this one we say it is about a free space wavelength. So that is about what we can say, that a factor about a T, that is about a microstrip line and that particular a thickness there. But in general, this this patch is nothing but a metallic patch here. Okay, this particular patch, and that patch, we can say that it is about the length is about a very very small there, and length is usually it is depending upon that what will be the height of the substrate. So this one we say this one is about the height of the substrate. This one is about the height of the substrate. Okay, this one, or we just draw here. I supposed to find out here. This one is about the height of a substrate here, and length, width we supposed to consider, and the thickness of the patch. These are the three factors to be considered. And then based on this, whatever the what you can say that a patch here, the length and width of the patch are dependent on the height of the substrate there. Okay, and that height of the substrate again it is depending upon that a free space wavelength. So both the factors are dependent on each other. Okay, so we supposed to consider that what will be the particular size of the patch here, and then if you consider that a field configuration, so this patch is nothing but what we can say that metallic one. This one is the ground plane now. So then how your field line will be looks like? This one is about your a field line, that we can say here a microstrip patch here. So it is about go down into the ground. Okay, to the ground now. Let me draw here. Okay, so this one means around it, whatever the a patch structure is there, we have a patch structure. So that's why we say that this is about your field, okay, field distribution of the given line. So now I'm supposed to I cut the section here. Okay. So now then a side view of this particular patch. In that case, how that side view of the patch will be looks like. Here we have a ground plane. This one is about a ground plane now for the patch. Okay. Then this one is about a small strip. This one. If I cut the section, I supposed to cut here. Okay, I supposed to cut this section here of this microstrip line. Then how it will look like? This patch will be look like. Okay, this one is about your patch. This one is about your patch. And then that patch it has, we say earlier, it has some particular length. This one is about what you can say that cut the section of the patch here, it has some particular length there. Okay, so we can say that the substrate it has some particular height. This patch it has some particular thickness, that is about T here. And then what will be the fill distributions for the given particular patch? If I say that a cut section, then in that case, okay, your fill will be at the center. Okay, so there will be what you can say that from the center here, we supposed to draw the fill distribution. So in that case, for half of the portion here, so it will be different now. Supposed to draw first now. Okay, then we have to find out that likewise here, the downward. This one is the upward now because it has a two slot, two radiating slot. Why two radiating slot? This one is about a one radiating slot, slot 1, it has another slot radiating. Okay, now this one slot, this side is radiating one, this side is radiating. So means this one is about a radiation pattern. So that's why if I cut now here, so it will be downward. So, okay, so we can say that this one is downward. Okay, so it will be upward now. Sorry, to consider that it will be a upward now. Okay, so if it will be upward, this will be a downward here. So that is about a field distribution for the given particular slot. So now we talk about here what will be the various types of patches available, okay, for the given particular line, for the given particular microstrip line. So I'll just draw the various configurations right now. You just remember that how this your this one is the radiating slot, this one is about a radiating slot, these are the radiating slot here, and these are radiating. If supposed to be I cut the section here, so I'll just see the one line. If I cut this section here, then I can see that these two different radiation radiating field here. Okay, now what are the various microstrip patch are there? Microstrip patch, there are the different types of shapes here. So that is about a square shape. Okay, even if it not, now I just try to draw now square properly. Yeah, this one is about a square, then a rectangular, then we can say that it is about to act as a dipole now. This one act as a dipole now. Then we can say that a circular one. Okay, this one is about a circular one. Then a elliptical one. Okay, then you can say that a shape will be a triangular one. So for each and every patch, if you consider that, so that current distributions will be different. Based on the current distribution, that radiation pattern, if you observe, that will be a different here. Now this one is about a disk sector. Okay, this one looks like a disk sector. Then a circular ring. Most of the people right now working on this circular ring. Okay, because it got the that what we can say that radiation pattern is good using this particular circular ring here. Okay, so then to develop or design, it will be very easy. That's about a circular ring. Then this one is about a ring sector. Now these are the various types of a patches. Okay, so mostly if you consider that what type of patch is preferred. Okay, so mostly people are preferring the square shape because whenever you are designing the antenna there, so in that case, so identical element is to be used to develop the array pattern. Okay, but in the case of polarization terms, if you talk, then if we are using a rectangular or square or a dipole or a triangular here, so then we'll get the linear polarized output. But if you consider that a other, okay, other elements, then we get the different that circular polarization. So how we need or for what purpose that antenna is to be used, what is our aim, whether it will be linear polarized output or for a linear polarized applications we supposed to develop or a circular polarization we supposed to develop. According to that, we need to use the various configurations of this microstrip patch antenna. Okay, so then we see that earlier for a microstrip antenna we have used a feeding technique. So how we are feeding the a microstrip antenna. So that is about a feeding technique what we have learned. So that is about a simple strip line. Okay, so that microstrip line is used to feed this patch antenna. So I'll again draw the antenna. Okay, that this one is supposed to called as a, okay. This one is about what you can say. This one is about your microstrip patch now. Okay, now this one. Now we are connecting this patch. Okay, this one is about nothing but a microstrip line. Okay, how we are feeding this antenna. We are using that a line to feed this patch antenna here. If supposed to be, if your antenna is not a, what we can say that, a square shape or a rectangular shape, if it is supposed to be a circular in shape, okay, if your patch is of a circular in shape, then at the center of a circle, okay, at the center of a circle, you just put the hole through this and then connect to this one. Okay, that this way we can use the feeding technique. Or if, or at any point, okay, at any section, if I cut the section of a circular one, so how it looks like. So this one is about a diameter of the circle one. Okay, now this one is about a diameter of a circle. Then we need to feed from this section, okay, from the bottom of this particular place or at the center here. And this one is about a your connector. Okay, this one is about your connector. Then you can feed this antenna if it is a circular one. So how we are feeding the antenna with the, what type of configurations we have. So according to that, we have to feed the antenna. Even we can feed using the slot feed here. Okay, we can use a slot line. Okay, so that this way we can feed the a microstrip antenna. Various techniques are there or various ways are there. So these ways are used to feed the antenna there. And if you consider the equivalent circuit of a microstrip line, the microstrip line equivalent circuit will be likewise. Okay, this one is about a equivalent circuit of a microstrip line. Okay, and then we need to match this microstrip line impedance to the equivalent of your whatever the patch we have. So what will be the impedance there? So then and then what will happen? Maximum power will be transformed. That's why we need to know about, for a rectangular patch, what will be the line model we are using. Okay, what will be the line model we are using. Okay, so according to that, we supposed to find out the what will be the feeding technique, or what will be the different patch according to that feeding technique. And from the feeding technique, we supposed to find out the way to connect the microstrip antenna. Then. Okay, so that's all about what you can say that a microstrip patch antenna. Then for the given particular microstrip patch, I supposed to draw a patch now. This one is about your microstrip patch. Okay, not full antenna. I'm just going to draw only the patch. This one is about your patch. Okay, and this one is about a strip line. That is, line is used to feed it. And this one is about your microstrip patch. Now, what will be the antenna here? This one is about the antenna. That antenna has a length L, and that width of this antenna is nothing but a W. And this one is about a small section. This small section, that this one we supposed to consider that a delta L. This one is the extended part that is useful for the feeding the a microstrip antenna. Then we need to find out what will be the width to height ratio. Okay, so what from this configuration we need to find out the what will be the width to height ratio. What height? Height means what? That is about a height of your substrate. Okay, I'll just draw here. This one is about a microstrip patch now. Okay, this one is about your microstrip patch now. Okay, so what will be the height here for this given particular substrate? Okay, this one is about a ground now. So what will be the height here? So earlier we have seen the configuration of a microstrip line. We need to know about that what will be the effective value of a dielectric constant, and we need to know about that what will be the width to height ratio. And from that width to height ratio, we need to we have obtained the other characteristic impedance equation as well as the what you can say that that loss and all other components that we have obtained. Now, but in the case of patch antenna, we need to find out what will be the that section, okay, small extended section, and their height. That ratio we need to find out. And based on this particular ratio, we need to find out what will be the effective length of this particular patch. And this effective length is used to obtain that what will be the fringing effect occur on this particular patch. The fringing, we can say that what will be the fringing factor. Okay, that fringing factor we need to calculate based on this what will be the effective length of the a patch. So now that's about a length. But when we design, okay, whenever we consider that designing the microstrip antenna, we need to know what will be the value of this particular W here, because this one is act as the radiator. Okay, this one is the radiating slot, this one is the radiating. So that's why for an efficient radiator here, we need to find out what will be the width of width of this particular patch. So width of this particular patch, because this one is act as a radiator now. If you consider in terms of a dipole, okay, okay, parallel dipole. Likewise, twice of Fr under root of mu 0 epsilon 0, then under root of 2 epsilon r plus 1. Okay, that is about it. Or we can solve with respect to the this one is nothing but a what we can say that this factor 1 by under root mu 0 is nothing but a v0 here. So we can say that we can rewrite the equation here in terms of what v0 by twice of r, and this factor will be as it is here. And then we need to consider that what will be the delta L here, that is about the length. Okay. Sorry, that's about it W. Then what will be the effective value? That is, effective value will be nothing but what? WR plus 1 divided by 2. Similar kind of thing we have seen earlier in a Microstrip line. 1 plus 12 H by W raised to minus 1 by 2. Okay, that is about the effective value of a dielectric constant. And then that effective value of a dielectric constant, we should know what will be the effective value of a dielectric constant there. And from that, we calculate that, okay, delta L. Okay, so how to calculate the delta L? That delta L is equal to delta L by H is the ratio is equal to 0.412, that is effective plus zero point 0.3 divided into W by H plus 0.264, okay, divided by epsilon effective minus 0.258, okay, then W by H plus zero point 0.8. This one is about a delta L by H. Okay, so this one is about a equations we require. So while designing, okay, any antenna, so we need to find out first what will be the W. Earlier expression we have seen the W there. Then what will be the effective value? Then what will be the delta L here? And then we can calculate that what will be the actual length, okay, of the patch. That is about L, the actual length of the patch. So now I'll write the value of the length now. Then L is equal to 1 by twice of FR, and then it has a effective value and under root of it is 0 epsilon 0. Okay, this factor here, then minus twice of delta L. This one is about the length of the a patch. Okay, this one is about L here. And the effective length, if generally we say that what will be the effective length of the patch, Okay, so then it will be what? L plus twice of delta L. Okay, that is about the effective length of the a patch here. So this way we can calculate that, or we can design the microstrip antenna here. What will be the width? What will be the length? What will be the delta L? Okay, so everything that we can calculate, and then we can design the a microstrip antenna. Okay, so that's all about what we can say that a microstrip patch antenna here. And for the microstrip patch antenna, so we have seen that a microstrip line for the given particular microstrip line we have seen earlier, uh, there will be a frequency value, okay, for the given particular strip line, or we can say that a characteristic impedance of a line. All the factors are depending upon that that what will be the size and a thickness of the strip line there. So with this, stop here, and we conclude the microstrip patch antenna that we have seen now. Okay, and in the next time we learn that a parabolic antenna and a dish antenna. So that's all about a microstrip antenna. So thank you all of you.